all end up much further apart than they were to start with. The distances between the button galaxies have increased dramatically. From a universal perspective, it's very clear that not one of them has stayed motionless at the center of the expansion. But from the point of view of a single button, like this red one, it looks as if every other galaxy has moved away from it, leaving it at the center of an ever-increasing void. The point is that the universe is getting bigger. The distance between galaxies is increasing, the space in between them is expanding. Our galaxy is not the center of this expansion, just a part of it. And this expansion is yet another lingering proof that the Big Bang did take place. And that's important for what comes next. If the galaxies are all flying apart, it follows that at some time in the past, they all jumped together. It's like dropping a jar full of marbles. In an instant, everything goes from being tightly packed together to flying apart at incredible speeds. The direction and speed of the marbles carry valuable information about the moment of impact. Similar information can be gleaned from the speed and motion of the galaxies in our universe. If we extrapolate backwards, we find that this moment in which everything was together happened 13 billion years ago, the time of the Big Bang. It seems that the more we look at the universe, the more evidence we find to support the Big Bang theory. By recognizing the CMB for what it is, stretched out light from the earliest stages of the universe, and by discovering that space is expanding, cosmologists were able to prove that the Big Bang is indeed a convincing explanation for why everything looks and behaves the way it does. But nothing is perfect. And like every good cosmological theory, the Big Bang is not flawless. Its flaws provoke some of cosmology's fiercest debates. To understand where these flaws come from, we have to go back to the beginning. Not the universe's beginning, but mine. I was born in Évora, Portugal in 1967. I like chocolate, playing soccer, and teasing my sister. I didn't like school or spinach. Two streets away lived another boy of my age, named Felix. Felix went to a different school, played with different kids, supported a different soccer team. Although we started life in the same town at around the same time, we never met. Just before my 5th birthday, my family moved away from Évora. For the past 40 years, Felix and I have led entirely separate existences. So, if you had to guess what Felix looks like now, what would you say? You'd be crazy to think that Felix is also 1 meter 80, weighs 85 kilos, and is a physics professor with subversive ideas about the speed of light. And of course, he isn't. Felix is fat, bald, and is a butcher. Today, he and I have virtually nothing in common, apart from the fact that we were born around the same time in the same region. It's exactly the outcome you'd predict. But that kind of logic doesn't seem to apply in space. If the basic Big Bang model is correct, opposite corners of the universe are so far apart that light, and nothing can travel faster than light, hasn't ever had the time to travel in between them in the 13.7 billion years since the Big Bang. They've been completely out of touch and should be utterly different, just like Felix and me. Observations, however, show them to be identical, a feature which the Big Bang theory simply cannot account for. It's as if Felix grew up to be like me in every single way. This unexpected Felix outcome is more properly known as the horizon problem. And it's a major problem. According to the standard Big Bang theory, there is absolutely no way these distant parts of space could ever have exchanged information of any kind. They are, always have, and always will be outside each other's horizon. Yet, the temperatures and other physical properties are too similar for them not to have been in contact at some stage. It's understating the issue to call this significant flaw the horizon problem. From the Big Bang theory's point of view, it's a catastrophe. Whatever you call it, it's one of the greatest mysteries of our universe. The job of cosmologists like me is to find solutions to this problem, while at the same time trying to preserve as much as possible the good bits of the Big Bang theory. Namely, that space and time, the universe, began in an unimaginably hot and dense state 13.5 billion years ago and has been cooling and expanding ever since. There have been many attempts to solve the horizon problem, some more convincing than others. One of the most popular fixes of the Big Bang theory is called cosmic inflation. And it works like this. Three weird-looking people are caught on security cameras in 3 different locations of the same city. These guys are kilometers apart, yet they are covered in the same distinctive bright orange paint. It turns out that 10 minutes ago, a paint balloon fell from the sky into the city center. It plastered everyone within a meter of its impact point in this particular bright orange. So it follows these 3 people must have been close to